Today we're going to talk about modeling direct variation. So direct variation, again, variation is something that we're going to talk about a lot. It's actually what the premise of graphing is. And not only that, but we're going to talk about direct variation this year, and then next year in Chapter 8, which is the first chapter you're going to do, we talk about inverse variation, joint variation, and we go back to direct variation. So the idea of how things vary really is really heavy in Algebra 2. Because like I said, this is basically what algebra is based on, right? So like geometry or shapes, right? So you see something in the world and you're trying to figure out what is that, why is it doing that? Okay, that's geometric approach. Algebraic approach is you notice something changed and you don't know why. Okay, I saw it here, 6 months later it's here. Why? What happened? What's going on? Math and algebra in particular is what's happening in the background that you can't see that's getting us from point A to point B. So the idea of variation is actually one of the big building blocks that the entire idea of algebra is actually based around. So the formula is pretty straightforward. So direct variation means as x goes up, y goes up, or as x goes down, y goes down. So it's in direct variance, right? So what does the word variation mean? What does the word variation mean in any setting? Okay, so it's a change within a system, right? Okay. Right, so variation just means we're going to take something and something's going to change, right? So for us, if it's direct variation, as x changes, y is going to change the same way. Okay? Or, so here as x goes up, y goes up because they're changing in the same direction. Or as x goes down, y goes down. So as x moves this way, y moves this way. Everybody okay with that idea? Yes, no, maybe? So we are going to be working with direct variation. All right? Now the formula for it, let me see where I wrote it. There it is y equals kx. So this should look familiar to you, right? What's our slope-intercept form? Y equals mx plus b, right? Y equals mx plus b. Does that look familiar or similar to that? Yeah. What's the difference? There's really no b, right? So what number goes here that would make b disappear? 0. So for us, what we've really got is point-slope form, or sorry, slope-intercept form, where m is k, and our y-intercept is always going to be 0. And that's what direct variation really means. Because if things are going at the exact same rate, then they have to start at 0, 0. Does that make sense to you or no? Okay. So k's technical name is the constant of variation, right? What's another name for slope? Rate of change. Okay, does that sound familiar to constant of variation? Variation means change, constant means the rate, right? So it's another way of saying rate of change. So direct variation is exactly the same thing as y equals mx. So we've already been working with it, okay? It's just like it's a special type of point-slope form, okay? And wow, I keep saying that. It's a special type of slope-intercept form, all right, where the m is a k and your b is always going to be 0. So let's take a look. So if I gave you this graph, right, this is our graph, this is our parent function for y equals mx. So what's the slope up here? How are we changing? 1 over 1. So my m is going to be a 1, right? And what's my b? 0. So this is the function that I'm going to be manipulating, but it's always going to be at 0, 0. So I can rotate it and move it around, but no matter what, it's always going to be passing through 0, 0. There's only like 3 graph problems, so I would say no. Most of this is actually algebraic. So, have I said write and graph a direct variation equation that has the given ordered pair as a solution? Any ideas where to start? Okay, so I know my graph is going to pass through 0, 0 because it's a direct variation, right? It says direct variation, so we know that the b is 0, right? And then what's the other point? Negative 7, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So if I gave you this line, and I said find the equation to get here, any ideas on how I would do that? Any ideas on how I could find the equation to this? Well, what did I tell you? What is this a function of? Direct variation. What's the equation for direct variation? Y equals kx. Okay, how many variables can I solve for at one time? One. Okay, I have a y, a k, and an x, right? Do I have any values? Did they give me anything? What's this? An x? What's this? Huh. You think I could plug it in and solve for k? Yeah. So I'm going to plug in my y. I'm going to plug in my x. And how do I get k by itself now? Divide by -7, right? So I get k equals -4/7. Is that an equation? No. An equation means that I need to have a y and an x, right? So I'm going to take this, and which of these values do I now know? So I'm going to just plug in my k. So these are actually two-part problems. So y equals -4/7 x. So all I'm really finding is my slope, right? So if you wanted to, you could go, what's 4 minus 0? 4, right? What's -7 minus 0? So I get a slope of -4/7. Because I'm passing through 0, 0. So I can use the 2 points to find the slope. Or I can do it this way and save myself from using a bigger formula. The connection is up to you guys. But remember, constant of variation is the slope. So if I have 2 points, I can find my slope. Okay, this is what I'm actually driving at for my answer. Okay, this is a specific point, correct? This is 1 point on my graph. How many points are on a line? Infinite. There's an endless amount of points on a line. So how do I turn 1 point into every point? That's what I'm asking you to do. So I'm giving you 1 point, and now with this equation, I can find any point if I plug in whatever x I want to use, right? That's the idea. Is I want you to go from a specific idea to a general equation, a general form, so we can find every point on a line instead of just 1 point. Everybody all right with that? Yeah? Yeah, and all you're doing is plugging it into y equals kx. Plug in your y, plug in your x, solve for k, and then rewrite the equation with the k value written in it. It's really simple if you don't overthink it. All right, the biggest issue that kids have here is you're like, it can't be that easy. It is. So, let's take a look. The variables x and y vary directly. Write an equation that relates to x and y, then find y when x equals 12. So there's 3 distinct parts to these directions. The first one tells you kind of what's going on, right? The general idea. The second part, we have to actually find a solution for it, write an equation. And then the third part, find y when x equals 12. So these are actually 3-step problems, okay? The biggest issue is that you keep trying to take shortcuts because you've always been encouraged to take shortcuts in math. In this section, it will hurt you. I'm going to suggest do not take shortcuts. Go the long way and everything will work out, okay? So, what's the first sentence say? X and y vary how? Okay, directly. So they're telling you that this is direct variation, correct? So what's our general equation for direct variation? Y equals kx. This is really important because if you don't know where to start, you'll never get to the end. Okay? So this tells us where our starting point is. So we know that we're starting with y equals kx. Okay? And then it's going to be like what we did on the other page, right? I have y equals kx. What information did they give me? An x and a y. So what do you think I'm going to do with that? Plug it into the equation. Okay, so my y is 8. I don't know k. My x is 4. What do you think I'm going to solve for? K. So get k by itself. What do you get? Divide by 4. So what's k? 2. This is worth 1 point. But did it answer the question? Is this an equation that relates x and y? No. When they say a function that relates x and y, you have to have an x and a y, right? So if I know k, do I have a function up here that has x and y in it? Yeah, right here, right? So now I have to back substitute. So plug in what we know, and we're going to get y equals 2x, and that's not a really good color. All right, so this counts as 1 point so far. So 1 point for the k, 1 point for the equation, okay? So we went from a specific point to a general equation, and now we're going to use that general equation to answer the final question. So what does the final question say? Okay, so what do you think I'm going to do now? I'm going to use my equation, and I'm going to substitute the number they give me, right? So what's the number that they gave me? For which piece? X. So I'm going to take my equation, and I replace X, if my computer calms down. There we go. Good boy. And what's 2 times 12? 24. This is point 3. 1, 2, 3. 3 points per problem.
So you just plug in the 12. You don't have to try and get an answer.
You already did. That's the whole point, is that these are all connected to the same idea. So we started with this equation. We found the K for the situation they give us, right? So we converted the 1 point into every point, and now they're saying use this equation to find the Y if I wanted X to be 12. So it's all the same line. Okay, so like you start off with 0, 0 and the 0.48, so you're like that, right? Find the equation of the line, and then what's the Y value when X equals 12? That's what I want to know. So instead of graphing it and doing all that, we're doing it algebraically because A is faster and B is more accurate. So find K, plug K in, get your general form, plug in the X value they give you to find the Y that matches it.
If I don't graph it and I do that, will I still
Yeah, you shouldn't graph these at all. The only ones that you graph are the ones that say, like this one, write and graph a direct variation equation. Okay, but there's only 3 of those. The majority of what we're going to be doing on your homework are ones like this. Find the equation. There is no graphing involved at all. You can use graphing to double check, but you should be strong enough in your algebraic skills to where you just use pure algebraic manipulation. So everybody okay with this type of question? So remember, it is worth 3 points. The issue is that a lot of you go from here to here. Well, you're missing this entire point. Okay? I want you to answer the question of writing an equation that relates X and Y. Everybody okay with that? Yeah? All right. So please just be careful. All right? 3 points, 3 answers. Make sure you include all 3. If you can't tell, I'm stressing that because guess what? Very few kids remember it. Okay? So please don't cost yourself 3 points. All right. Identify direct variation. Tell whether the equation represents direct variation. If so, give the constant of variation. So, if something actually models direct variation, what's our equation? What's our equation for direct variation? Y equals kx. So what we're really saying is if I can make this look like this, then the answer is yes, this models direct variation. If it looks like anything else, then I just put a no. So what's important here is which variable is isolated in this equation right here? Y. So what do you think I'm going to do with this equation? Isolate Y. So walk me through it. What's my first move? Add 5x. Get Y by itself. Y equals 5x over 2. Do you think that represents direct variation, yes or no? Yes, it does. Do I know what the K is? K is just some number, right? So if I get some number times x, I'm good, right? What does 5x over 2 really mean? Well, this means 5 halves times x, correct? Is everybody okay with that connection, that this mathematically is the same as this? So can I get y equals a number times x? Did I get that? Then that means that I instantly have direct variation. Everybody okay with that, yes or no? So in this section, that's what they're going to ask you to do, right? Get y by itself, and if your result is y equals a number times x, then you're putting yes. Anything else, you put no. Okay? So what about this? How do I get y by itself? Divide by 5. These cancel. I get y equals negative 4x over 5. So what do you think? Yes or no? Yes. Okay, and the big key when you have fractions, okay, if x is in the numerator, you're going to have direct variation. If you have a fraction with an x, right, and just that, nothing added or subtracted, if x is in the numerator, then you can split it apart in this fashion, okay? If x winds up in the denominator, then it is not direct variation. All right, so just look for the placement of x. All right, if there's anything added or subtracted, it's instantly not going to be direct variation because do I have anything added or subtracted here? No. Okay? So isolate y and then analyze what your result is. If you get y equals a number times x, then you are showing direct variation. And I didn't answer the second part. If so, give the constant of variation. So I need a k, and I need a k. So what's the k here? 5 over 2. And what's the k here? Close. Negative 4 over 5. So be careful that you include that neg. Is everybody good with that? Yes, no, maybe? This is actually pretty easy if you have a calculator. So for the next section, you are going to want your calculator, so go ahead and bust them out. Does the following table represent direct variation? This is actually a lot easier than it looks. So again, what's my formula for direct variation? Y equals kx. So I'm going to be using this, right? What's k stand for again? The slope, right? The constant of variation. For us, the whole idea behind the constant of variation is that things can't change. Okay? But our equation involves a y and an x. So what that means is I'm basically going to calculate my k at every single step. Okay? If k never changes, then what do I have? Direct variation, because that means that k is constant. Is everybody okay with that idea? Yes, no, maybe? Okay, so if the variation changes, then it is not direct variation. Is everybody okay? So, algebraically speaking, if I asked you to solve for k right here, how do you get k by itself? In this equation, if I asked you to solve for k, how would you get k by itself? Divided by x. So k is actually going to be equal to y over x. We're using this idea right here. So make sure you have that written down in your notes somewhere. Okay, when they give you a table, how you find k is you take your y value off the table and divide it by the x value on the table and see what number you get. And what we want is the k's to be exactly the same at every single step. If k is the same at every step, then yes, we have direct variation. If k changes at all on any step, then it is not direct variation. Is everybody with me? Okay, so up first, what's my y? Top or bottom? Bottom. And what's the x? Top. So what's 215 divided by 1.8, please? So again, like I said, just use your calculators, right? What's 215 divided by 1.8? 119.4, repeating. So this is my k for the first xy pairing, right? If this is direct variation, that has to stay the same at every single step. So what's 290 divided by 2.4? 120.3? 83, okay. What about 350 divided by 2.9? 120.6896. Okay. What about 430 divided by 3.6? What's 565 divided by 4.7? And 695 divided by 5.8? 119.8275. Okay. So if you take a look at our k's, right? Are the k's exactly the same? No. But when we draw a straight line, if I just randomly pick points, are we going to always get exactly the same slope? We're going to be really close, right? But I'm going to have decimal round-off error and all kinds of stuff going on, right? So if you take a look, are my k's really close to each other? Yeah. Okay, I mean, I'm between a 119.4 and a 120.8. That's pretty darn close, okay? Especially because we're looking at body length to tooth length. That's not exactly a super strong correlation, usually, right? But for sharks, it actually is. Yeah, that's where this data came from. So, like, the bigger the shark, the bigger the tooth. Does that make sense? But it's actually at a constant rate. So if a tooth came out of a shark, so like if you're walking down the beach and you find a shark tooth, you could actually calculate, if you know the formula, the length of the shark it came out of. What, 1.8 centimeters? Yeah, that's, I mean, it's still 215 centimeters, but that's not that much. All right. So everybody okay with what's going on? So do you think this would be a yes or a no? Do you think this model represents direct variation. Yeah, because the k's are insanely close to each other, right? Yes. If it's a no, it'll be really obvious. Like your k will be like, it'd be like 119, and then the next k would be like 80. Okay? Big swings mean not constant of variation, or no constant of variation, which means no direct variation. Okay? But if the k's are really close to each other, and I mean really close like that is, then that's a yes. Okay? Yes, sir.
How many of these do we have on
I think there's like 3 or 4. It's not a ton. Okay? Because all you really need to show me are the k's. So just k equals, and then it's a yes or no answer. And then you're done. And you move on to the next one. Okay? So the biggest issue is that direct variation is not that complicated as long as you're just doing what it says. Okay? The biggest issue that you're going to run into is you're going to think there has to be more to it. And there really isn't. In most of these settings, you just use direct variation, and it's a very simple, quick little process. Okay? So you're going to have to fight the urge of, I can't be done. You probably are. Okay? And if you're not sure, do an odd problem, look in the back, and see if your answers match. Okay? So, here's your assignment. So the 4 through 7 have to actually be graphed. Okay? 11 through 14, 18 through 20, 24 through 26, and 31 through 34, no graphing involved. Okay, 31 through 34 are the tables. And then everything else is just using the equation. Okay? So please get this written down. And we've got 5 minutes left. So, real quick. If homework's assigned today, tomorrow, what should you do as soon as you walk in? Right. Okay, put up problems that you want to see done.